afternoon. You ready to get this done? Wrap up the week?
One more session.
You are the dedicated crowd because here we are, the last session of the conference. You could have gone to any of the other sessions that are going on concurrently with this one, or you could have gone home. But no, you're here, so I thank you for that. This is going to be a fun talk. I've been looking forward to this talk more than any of the other ones. We're going to talk about using Spring Social to connect your Spring applications with the various APIs, lightweight APIs that are available out there on the internet. And there's who I am. I'm the Spring Social project lead. And if you like to follow me on Twitter, I mean, it wouldn't be a very Spring Social or a very social talk if I didn't at least give you some Twitter handles to follow. So there's my personal one as well as the Spring Social specific one where I would tweet more Spring Social oriented topics. Very happy. I just recently got that set up. I had to coordinate that with another group to get that from them they weren't using it anymore. Let's talk about why you'd want to do this. Well, the web is social. I mean, truly, the modern web is a social web, and you probably know that already, but just to kind of drive the point home. Just 2 weeks ago, Mark Zuckerberg was announced on his blog that there are now 1 billion active users of Facebook. That's a whole lot of active users, by the way, if you haven't figured out how big that is. 1 billion, I just can't even fathom that many people, period, never mind on Facebook. It's still a small fraction of the Earth's population, but when you start thinking about the connected population, the population actually, is certainly old enough to use Facebook, but also who might actually be on the internet and have machines to do that. There's actually a pretty significant chunk of the Earth's population. So that's a huge number. 552 million daily active users, at least in June. That's a lot daily who are using this every day on Facebook. So never mind the exciting stories about scalability. This is where your users are. This is where your customers are. This is where the people, whether you realize it or not, this is where the people who you're working with and the people who you're building your product for, this is where they're living when they're not using your app. Okay? And just show of hands, out of curiosity, how many of you have a Facebook account? How many of you have a significant other who has a Facebook account? And just out of curiosity, how many of you have played Farmville? Interesting. Okay. Okay. Farmville, insanely successful game on Facebook. Twitter. 517 million accounts. Now notice I didn't use the word active there because there's a lot of variation in what a Twitter account means. There's certainly, for example, I have like 5 or 6 different Twitter accounts. One I use for tests, one I use for personal, one I use for Spring Social, one I use for a handful of other things. So that's not a unique user. That's certainly a unique account. I think at one point they were estimating that there were roughly somewhere between 100 million and 200 million individual users using it actively. I didn't put that number up here because I wasn't clear on the exact number, but it's around there. LinkedIn, 175 million users as of August 2nd. That's a lot of users too. It's not nothing to sneeze at. And how many are here on LinkedIn? And if I have to ask, how many are on Twitter? How many of you have tweeted since I've started talking? Yeah, there we go. See? Anybody here use Google Plus? Yeah, a surprising large number of hands. I mean, Google Plus is still one of those nebulous things, and I'm on Google Plus. I use it. I think it's actually quite a really nice thing they got going on there. I just haven't quite absorbed it into my normal social flow, and I wasn't clear on who else was either. But apparently, it's a very popular framework, and we could go on and on. There's Foursquare, and there's Gammer, and there's all sorts of other social sites out there. And this presents some opportunities because nearly 4 in 5 active internet users visit social networks and blogs frequently. And this came from a Nielsen report here that came out sort of late last year, early this year. And this gives you opportunity to build up and reinforce your brand loyalty with your customers, hear stories from them, let them tell you how you're doing. And certainly if you say something good about one of your the businesses you frequent, they might do something good for you. If you say something bad, they might attempt to correct it. I heard a story where a gentleman had, I'm going to tell you 2 quick stories on how this works. I heard a story about a gentleman who was flying from one city to another, and he had a layover in some city where there's a restaurant that he really enjoys, a steakhouse he really enjoys, and he was just bummed that his layover wasn't long enough to enjoy his favorite steak. And so he tweeted about that he was just really bummed out that he wasn't going to get to enjoy his favorite steak. When he arrived at the airport where he was going to have this layover, there was a representative from that steakhouse there with his favorite steak waiting for him because he had tweeted that. And it was just it's a small little detail on their part. They didn't have to do that, but it certainly created a great deal of loyalty. He was already a fan of theirs anyway. He's a bigger fan now. On the other side of that, every year around this time of the year, it's almost that time of year again, when we're going to start hearing commercials on the radio and on TV for mattress companies who are going to try to unload the last year's product, and so they'll have what they call a year-end mattress sale. But unfortunately, when they say it really fast on the radio, it sounds like year-end mattress sale, and nobody, I don't care what kind of deal you're getting, wants a year-end mattress. I tweeted that about 2 years ago, and I had almost instantaneously a follow-up, a reply from one of the representatives of one of those companies saying, duly noted, we'll fix that next year. They didn't. So I tweeted it again last year, and we're waiting to see how it works out this year. But yeah, they do listen to you, and they do listen to you should listen to your customers who are on these social networks as well. It does drive qualified traffic to your site. For example, Facebook has really taken off with this using the various ways of activities that people can post. So if I'm listening to a song on Spotify and I have linked up Spotify with Facebook, suddenly all my friends know that I've listened to that song on Spotify. Now, I don't do that because I really don't want to annoy my friends with the type of music I listen to. But if I had done that, now my friends will see that, and they might think, well, I appreciate Craig's taste in music. I'm going to listen to that too, and I may end up buying an album from that artist. It can enhance the user experience, and to a great degree, this is really good too, because you may not actually have a social application of your own, but people kind of expect, and it's increasingly expected, that applications on the internet have some sort of tie-in to the other places they live on the internet as well. A very simple case of this that I've seen is you go to a lot of these news sites, you'll see an opportunity to post comments about some news article that you just read. More often than not, that's actually Facebook comments. It's actually posting back to Facebook using Facebook comments as its engine for comments. But going back to the Spotify Facebook situation, that's another situation where it enhanced the user experience. I am now able to socially share and able also socially learn about new artists because of the friends that I have who have listened to some artist on Spotify. The thing is, APIs are everywhere. And almost every online social network out there, almost every one, I know of one or two that don't, but almost every one has a REST API. In fact, most of them do, and they just don't publish it. The ones that, even the one or two that I'm thinking of, they just don't publish it. The two I'm thinking of, by the way, immediately are Pinterest, and they keep saying they're going to publish theirs, and they haven't, so I'm hoping someday they will. And Google+, they have an API. It's very thin. At least their public one is very thin, the one they've published. We're hoping that at some point that's going to grow out as well. But almost everybody does, and so this is an opportunity for you to build applications. You build your server-side applications that interact with the various APIs out there. But I should also mention that this is not just about the word social. So Spring Social, unfortunately, I think it's a great name. I think it's got a good catch to it. It draws people's attention. Certainly you came in here to hear about it. The fact of the matter is, though, it's not just about social. It's a little misleading. The truth is, any API that you might want to connect your application to is a candidate for using Spring Social. And we'll talk a little bit more about that in a moment. Oh, well, actually, this is that moment. I had forgotten that was quite next. If you look around, there's actually some gentlemen who have built, in the Spring Social community, have built extensions to Spring Social to work with QuickBooks Online, Salesforce, and GitHub. Now, GitHub is somewhat social. I will grant you that. It is a sort of social network. But I wouldn't think of QuickBooks Online or Salesforce as social networks at all. I wouldn't think of another example that I didn't list up here. I would not think of Netflix as a social website. They used to have some social features to them, but that sort of went away. They don't have social features anymore, but nevertheless, they still expose an API that you could write against and somehow expose their information and allow your users to work with Netflix, work with QuickBooks Online, work with Salesforce, even though they're not social networks. It's just an API somehow secured, probably with OAuth, which we're definitely going to talk about. Here's a real quick, simple taste of what it's like to work with one of these APIs. For example, if you saw the keynote on the first night, you saw that there was a demo where they used Spring integration to go pull some tweets about Justin Bieber and Obama and Romney, and they pulled those up and compared the numbers, and that was great. Under the covers, they were using Spring Social, and under the covers, Spring Social is essentially calling this exact same method or the same URL here. And so you enter this URL into your browser, and you can try it now, and it will return some JSON back with whatever happens to match S2GX. Fantastic. You could do the same thing with Facebook. You can go to graph.facebook.com/something, and it will give you data back. Here, I've gone to my personal account on Facebook. I could have just as easily have entered that number in the ID there. Habuma is my username that is an alias for that ID, but if I put that number in, that would have also worked. I'll give you the quick skinny on how Facebook API works. It's really super simple. There's two URL patterns. One that takes an object, which is what this is, some object ID, or one that takes an object ID and some connection off that object. So if I wanted to see a list of my friends, the URL would be graph.facebook.com/habuma/friends, I believe is the endpoint that I'd be looking for. And it would give me a list of those. That's Facebook's Graph API in a nutshell. But notice here, I would imagine that Facebook knows a lot more about me than what you're seeing on this slide. In fact, I know for a fact they know a ton more about me than what you see on this slide. And so there's obviously something missing, and we'll have to talk about how we're going to get that. Another example you might want to do is post a tweet to Twitter on someone's behalf. And here I'm using Spring's REST template to do that. You can use a lot of different things. You could use that REST shell that was shown the other night. That would be another option. And so what you would do is you would post to this. Now I'm still using, in this case, I'm still using Twitter's 1.0 API, which has now been deprecated. Well, I'm going to mention that a little bit more details about that later. It's been deprecated in favor of 1.1, and it will go away in March. But currently, it still works. And so if you were to try this, you would say something like tweet hello, or you'd say add to the status property hello from S2GX, and you would post to the statuses update endpoint, those parameters, and expect to get back some object, and you would be happy, right? Things would work. So here's what happens. Crap happens. It doesn't work. And what you get is a 401 error back. And the reason you get a 401 error back is because there's no indication of who we're posting this tweet on behalf of. We don't know who the user is. And even if we knew who the user was, for example, perhaps we knew that my username on Twitter is Habuma, even if we were to somehow specify that in this request, we don't necessarily have my permission to do that. And that's a very important key. If we allowed a client to just post tweets randomly just for anybody without their permission, that would be chaos. You can imagine how that might work. So we're going to deal with that too when we talk about what it means to secure the social web. Well, there's some common security mechanisms that I've seen used, and I categorize them in three ways. Two of the categories are very clearly defined, the other one's not so much. There's HTTP basic. Up until a few years ago, that was exactly how you would work with the Twitter API. You would basically give the Twitter API some user's username and password via an HTTP basic header, and it would work on that user's behalf. Downside of that is the application that is using that is now aware of the user's credentials, which is problematic. I'll touch on that in a moment as well. I've seen a bunch of proprietary solutions. I've seen a lot of people who try to overcome what HTTP basic limitations there are and try to do it themselves. And the bad side about these different proprietary solutions is, although some of them are actually quite good, they are proprietary. And proprietary in the sense that it's not that they're not allowing you to use them. They would certainly be happy if you wrote a library to use their security mechanism, but then you're going to find yourself writing a library for each and every one of these folks who offer that. And so this is where standards come in, and there is clearly one standard in this space that solves this problem. There's a handful of security standards we could talk about, but none of them really address the specific problem as well as OAuth does. And that's what we're going to focus on for the next few moments, and then I'll turn it around and I'll show you how Spring Social helps you work with that. So OAuth is an open standard for API authorization, and that's the key word here. It's not about authentication. It's not about finding out who the user is. It's about finding out what the user is allowing some application to do. Now, I will go ahead and tell you, there are some folks out there who have done some pseudo-authentication using OAuth. In fact, there's an entire standard or spec being built out currently known as OpenID Connect, which is essentially OAuth with some special restrictions on it so that you can do the pseudo-authentication. That said, though, that's not what OAuth's purpose in life is. OAuth's purpose in life is to do authorization on behalf of a user. And this is important. The user is the security administrator. The user is in charge of deciding what is allowed and not allowed. It's not some system rules in place. It's not some other human system administrator who gets to decide this. It's you. It's when you're using an application and that application wants to use an API on your behalf, you get to decide whether it's going to be allowed to do that or not. Now, there are 3 versions of OAuth in play. There's OAuth 1.0, OAuth 1.0a, and OAuth 2. And OAuth 2, interestingly enough, is not finished yet. It hopefully will be soon. In fact, it's at draft 31, at least the last I checked it was, unless something happened in the last 24 hours. It's at draft 31, and that means we got 33 different versions of OAuth we need to concern ourselves with, but it's really not that bad. There's really only a handful you need to think about. So yeah, I'm hoping it's going to be final soon, but I can't promise anything. I'm not really directly involved in that other than the fact that I just monitor their mailing list, and I'm hoping that they're going to finalize that soon so that we can put this to bed. But yeah, even though OAuth 1.0 was around, it was clearly the first version of OAuth that came about. There was a few security holes in it. Nothing significant, but if you were to sit down with a scratch piece of paper and a nice fresh cup of coffee and think it through, you would probably see how the security holes would play out. And so OAuth 1.0a came along and fixed those security holes. I only mention OAuth 1.0, even though that it had the problems, because there are still APIs out there who are secured with OAuth 1.0. I'll give you a couple of examples. Dropbox is secured with 1.0. Tripit is secured with 1.0, and MySpace. Anybody here still use MySpace? New MySpace is looking promising, but at least the historical MySpace, yeah, it's still secured with 1.0. And so if you were building an app against MySpace, if you were building an app against Tripit or Dropbox or anyone else, there's actually several others who are still on 1.0, you're going to have to know how to deal with that as well. And so I'm going to teach you how to deal with OAuth, and then I'm going to tell you how you don't have to know that at all. So, you know, when you were in college and you were in calculus and you learned how to do all these different things, and then after you stressed over it and failed and flunked a few tests, they finally showed you the cheat way. Well, that's what we're doing today. I'm going to show you the hard way first, then we're going to show you the easy way. But first, let's get another basic feel for how authentication could work, an authentication-centric API. So we have some API over here that's holding some data that belongs to the user over there, and some application. Here I've just shown a screenshot of Greenhouse, but it could be anything. And Greenhouse wants to access my data or maybe post some data on my behalf to this API. So here's what's going to happen. Greenhouse is going to ask me, hey, buddy, can I have your username and password? I mean, what could possibly go wrong? You can trust me. There's no reason at all to think that I'm going to do evil things with your credentials, right? And I say, yeah, why not? I'm gullible. I'll give that to you. Here you go. Here's my username and password. Even though we've been told, but every time we're given usernames and passwords, we're told these are yours, these are secret, and yet they're not secret if you give them away to somebody like this. Well, sure, why not? And so then this kind of thing happens, and we move on, and pretty soon this is spamming correct fit. Now, Greenhouse would not do that, but some application could very well do evil things with that by sending my credentials in an HTTP basic header. Well, that's problematic. It's problematic in so many ways, because number one, they have my credentials. That's bad. In fact, there's no reason at all to think that they couldn't use those credentials to go into that API, change my password, locking me out completely, and then just running havoc on in my name. That would be bad. And if I wanted to stop them, there's very little recourse I have. Assuming they haven't changed my password and locked me out, the only recourse I have is to go change my password, which means now I've shut out all the other APIs that I can trust, that are trustworthy, that I've given my credentials to. So that's obviously bad. Well, here's how a user-administered authorization works, such as OAuth. And this is more of a generic a view of it. OAuth, it's a little different depending on which version of OAuth, but generically it works a little like this. Greenhouse says, I would like to get a list of Craig's friends. Is that okay? Can I do that? And so the API turns around and asks me, Greenhouse wants to see your friends. Is that okay? I say, I guess that's okay. But at least I'm trusting the application where my data is kept, not the application who's trying to get into that. I say, yeah, I guess that's okay. And it says, okay, Craig says okay, and it's going to give him a token, a valet key of sorts that says, here, every time you come to this API, carry this token with you in the request. And if the token is valid, if Craig hasn't revoked it, if it hasn't expired, if it actually is scoped appropriately to get what you're asking for, I will be happy to provide you with whatever data you're interested in. Otherwise, too bad. Craig said no. Okay? And the big benefit of doing it that way is if, for any reason at all, I decide that I can't trust that application anymore, all I need to do is revoke that token. Because the token is granted on a per user, per application basis. So if I no longer trust that app over there, I revoke that application's token. All my other applications who I do trust, they're still going to work just fine. I don't have to change my password. Well, this is going to get scary. And I'm showing you the scary slides on purpose because I want you to be frightened at this point. Okay, I really do. So let me show you how OAuth 1 works. And this is kind of a generic OAuth 1 thing. It's actually more geared toward OAuth 1.0a, but it's almost the same as 1.0 in how you would go about getting one of those tokens. We start off, when you see this slide over here, or this diagram off to the side over here, anytime you see a dotted line, that is actually a browser redirect. We're in someone's web browser and we're redirecting to somewhere else. Anytime you see a solid line, that's a back-end REST API call, okay, just to keep that clear. First thing we do, actually I said that the wrong way around. Dotted lines are REST API calls, solid lines are redirects. I was looking ahead and thinking how OAuth 2 works. Solid lines are redirects, dotted lines are REST API calls. So the first thing we're going to do is we're going to ask the API for a request token. And the request token is useless, really. It's not useful for actually accessing the API. It's useful for continuing this process. And it's not terribly clear what the request token's for, but it does end up being used in the course of this process for doing things like encrypting some of the data that's sent across. It's used as part of the key for doing that encryption. But other than that, it really doesn't serve a whole lot of purpose. So the client will get that request token and will turn around and redirect the user's browser over to the client. So at this point, this is like Twitter. Twitter is 1.0a. It'll redirect over to Twitter, and among other things, it'll pass along the request token. It's going to pass along the client's ID. It's going to pass along a few other things. And at this point, you're going to see something like this in your browser show up. Anybody ever see this before? Yeah. This is what's going on. It's saying, hey, it's okay. Spring Social Showcase wants to use your account. Is that cool with you? And it's also going to tell you what you can and can't do, what it's going to be allowed to do and what it's not going to be allowed to do. And if you say no thanks, what it's going to end up doing is pretty much redirecting back to the original application with some sort of error code or whatnot. And actually how that is handled is not defined in the spec. And unfortunately, different providers deal with it differently. Twitter, I happen to know, does redirect back to the original site with some sort of parameter in the URL, but I can't remember now what that parameter is. But it will redirect back if you say no. But if you say yes, then it's going to redirect back. And in the course of the redirect, what it's going to come back with is an authorization or a verifier. And this verifier, this is actually only in 1.0. In 1.0, this is only in 1.0a. In 1.0, there was no verifier. The verifier is one of the mechanisms they use to plug up that hole. So you get this verifier coming back, and now we exchange the request token, the verifier. We encode it using the secret, the shared secret that came along with the request token. We do a few other snazzy things, and we make another request back to the provider, to Twitter, for example, and say, hey, here's all the information we got. The user has authorized. Please give me an access token. Now, this verification is only good for a short period of time, like a couple of minutes. If you don't act on it right away, you have to go through this whole step again. But once if you do this right away, you'll get back an access token. And upon receiving the access token, now you can make API requests to your heart's content. All you have to do is make sure that you use that access token to sign the request for every single request you make to their API. Well, what does it look like to sign a request? Well, piece of cake. You create a base string. You sort all the query parameters. You Also do some encoding on all the parameters. I failed to mention that. You encode all the parameters, you sort them, you concatenate them with an ampersand. You take whatever the HTTP method is, whether it's a GET or a POST or what have you, you put an ampersand, you put the URL, you put an ampersand, and you put all of those other parameters that you've sorted and encoded down. By the way, that encoding, that's tricky on its own. It's not quite URL encoding. It's URL encoding with about 6 or 7 exceptions in play. And if you get any of those wrong, it just doesn't work. Then you take and then use the access token's shared secret as well as the client's shared secret. You encrypt, use that as a key to encrypt this base string that you created up at the top. Now, HMAC SHA-1 is common. That's what pretty much everybody uses, although the spec does allow for plain text, which nobody uses because it's not secure, or RSA SHA-1, which, as far as I'm aware, nobody uses because it's maybe a little too secure and a little bit too complicated. I have not yet seen an API that uses RSA SHA-1, but the spec does allow for it. So you encrypt it. Now, at this point, you have what's known as the signature. And then you add the authorization header to the API request, which looks a little something like this. Pretty simple, right? Everybody understands what I just showed up on the screen, right? It's clear, crystal clear. Well, it's got a lot of interesting things in there, such as the signature we got. We got a version, which, by the way, is always 1.0, even if it's 1.0a. We have a nonce, or a once and only once number. That has to be a once and only once used number, otherwise it won't work. We tell it how we arrived at that signature. We tell them what our consumer key is so that they know who the client involved is, because the client themselves has to authenticate with the provider in the course of doing this. We pass along our access token, interestingly enough, in plain text, and we also give a timestamp. So the timestamp and the nonce and a few other things, these canonicalize the request so that we know we're not sending a duplicate of the request. It also, some of the encryption around the signature helps us make sure that in fact the user did authorize this and that the token that's being presented, it wasn't just contrived by the client. It really is a good token. And so we do all this and everything works, and it's just beautiful, and I'm sure everybody here is just really happy with how this works and has no questions, right? Now, this is a pain. This is a huge pain. Speaking from experience, if you screw up anything in that process, just as little as missing one of those encoding exceptions, you will spend, in my experience, 3 days trying to figure out where you missed it. It is impossible to find. It's difficult to debug. It's no fun. My recommendation to you is to never do this. Instead, if you must work with OAuth, use a library to help you with that, such as Spring Social. Well, OAuth 2 made things much simpler. There is no notion of a request token, and the reason there's no notion of a request token is because there's a lot less encrypting going on. We primarily use that request token for encrypting purposes. It served very little other purpose, so since we're not going to do as much encryption ourselves, we don't need that token anymore. Instead, we're going to leverage HTTPS for encryption. We're going to take advantage of the fact that if we make the request over HTTPS, that will be encrypted already. It's safe enough. There's no signature, there's no canonicalization of the request, there's no timestamps, there's no nonsense. It's really simple. The authorization header turns out dumb simple when we're done. There are multiple approaches and ways to getting at an access token. There were a handful of different ways of getting at an access token in OAuth 1. There's a few more that actually come about in OAuth 2, and each one of them presents a different capability. And the ones we're going to focus on are authorization code, implicit, password, and client credentials. Those are the 4 that are defined in the OAuth 2 core spec. The OAuth 2 core spec, by the way, also defines a 5th category that basically says, now maybe I'm misreading it, but my understanding of it is, if you don't like any of these, go do whatever you want to do, and we'll just call it OAuth anyway. And I don't like that one. That just feels wrong to me. Maybe I'm misrepresenting that. Maybe I've misread it, but that makes me feel uncomfortable. These are the 4 that are most going to be used and are going to be consistent across most of the OAuth 2 providers. Scoped authorization, whereas with OAuth 1, you either granted access to an API or you didn't grant access to the API. Your scope was yes or it's no. In OAuth 2, you have the opportunity to allow the client to ask for specific rights. They don't necessarily have to have access to the entire amount of your data. They can have access to very small bits. For example, a very common thing for the lazy APIs out there is to offer both read and write access. So a client could only simply ask for read access. They don't need to write to your Facebook wall. They just simply need to read from it. They might be able to do that. Or they might ask for write access in case they want to write it. Now, Facebook, that was probably a poor choice of words there because Facebook actually takes full advantage of scoped authorization. They have several dozen, possibly even 100 different scope values you could give it, down to very fine grain, down to can I see the user's birthday? Can I see the user's email? Can I post to their wall? Can I read from their wall? Can I see their friends? Things like that. Very fine detail. And it's really a lot of fun. At least it was up until about a year ago. It was a lot of fun to go ahead and ask for everything. Because then that dialogue where it said, here's what the app wants to do is about this long. They've reworked the dialogue over the last year, and it's not as fun as it used to be. But I do, on another machine somewhere, I have a screenshot that was stitched together from several screenshots because it was so big where I asked for everything just for fun. I keep meaning to work it into one of these talks, but I just haven't yet. It was a lot of fun, though. Short-lived tokens, long-lived authorization. That's a key point here. In OAuth 1, tokens were good until the user explicitly revoked them. They were essentially good forever unless the user went in and said, no, I don't trust this app anymore. In OAuth 2, it's a little different. The tokens can expire. They can have a short life to them. But that doesn't mean that the authorization is no good anymore. It just means that token representing the authorization is no good anymore. And so you have the opportunity to go ahead and allow the user to authorize your application, use the token until it expires, and after it's expired, go and ask for a new token and not even bother the user with that detail. Because the user doesn't need to be bothered. The user has already authorized your app. But to keep the token from falling into the wrong hands and at least reduce the window of opportunity for it to be misused, tokens can expire now. And like I said, it's not final. It is currently at draft 31, the last I checked. But it hasn't changed dramatically since draft 14. Nothing significant has happened since draft 14. And draft 31, in fact, has been in place for, I don't remember the exact date, but it's around 2 months now. So I'm getting the feeling that this is getting close to final. Not only that, but just, chatter on the mailing list feels like it's kind of final. Well, here's how the authorization code grant works. It's very much like OAuth 1.0a, except that we don't start by asking for a request token. We don't need one of those. Instead, we immediately redirect to the provider, and we ask them for authorization. It's at this point that something like a Facebook dialog would pop up or a GitHub dialog would pop up and say, hey, is it okay if this application has access to your information? And you say yes or no, and if you say yes, we redirect the user back to the client with an authorization code as a request parameter. Well, the authorization code is essentially, it's a different name, but it's essentially the same thing as the verifier that we saw in OAuth 1.0a. We take that authorization code, we take our own client credentials and a few other things, and we make the call back to the provider and say, please give me an access token. They will grant you an access token, and you use that on every single request thereafter. Very much like OAuth 1.0a, with the exception that the details that you don't see on this slide are significantly simpler, but also there's no need to get a request token. Okay? Now, before I show you what that header looks like, that authorization header looks like, and I will show you that about 4 slides from now, I'm going to show you what the other 3 grants look like. There's implicit grant. Now, whereas authorization code grant was really made a lot of sense for page-based web applications where it seems natural to redirect the user to another site and then redirect them back. Implicit grant, it's still somewhat natural to do that, but the idea of implicit grant is not to allow the server side to access your account information or your profile or your friends. It's to allow some client side piece, some JavaScript widget probably, some very small piece, not even an entire JavaScript app necessarily, just some small little piece of JavaScript functionality to access your account information or your friends or post tweets for you. Well, it's much more simplified in the sense that we redirect to the provider, we get the user authorization just like we did before, but instead of getting the authorization code back, we get the access token back immediately. And we get it in a fragment parameter. And the nice thing about having it come back in a fragment parameter is there's some limitations on who gets to see that fragment parameter and who gets to work with it. One of the folks who gets to see it certainly is the JavaScript code on the client. Therefore, they take that access token out. They use it for whatever purposes they need. Now, the one thing about access tokens that come over on implicit grant is they should expire just like they would with authorization code grant. They don't have to. Technically, per the spec, they don't have to, but they should, especially for implicit grant. They should expire, and if they do expire, there is no notion of a refresh token. Now, in authorization code grant and as well as the other grants, if a token expires, you probably, depending on your provider, you were probably granted a refresh token along with it. You store both of those securely in your database somewhere. When the access token is no good, you dig up that refresh token and exchange it for a brand new access token. That's how it's supposed to work. Facebook doesn't do that, but most everybody else does. And that's how the spec says to do it. Well, with implicit grant, there is no refresh token. The idea here is this is a less secure environment already because we're living in the client. There is no way that we can trust a JavaScript client to securely store a refresh token and an access token. They thought this through. I've thought this through. I've tried to think of ways maybe we could shove it in local storage and encrypt it, but no, if you encrypt it, the encryption key is still going to be in your JavaScript, so it's not going to be secure anyway. There's no way you can really trust the client side to store these tokens securely. So the idea here is we're going to allow it to happen. We're going to reduce the window of opportunity, and we're not going to allow them to use a refresh token to get a new one. It is, again, commonly used by in-browser JavaScript apps and widgets. I would say for your big single-page applications, like something you might build with Backbone, although you could do it this way, I would almost advise not doing it this way, and instead go ahead and do one of the other options, probably the authorization code grant, because that allows you to share that token with the server side and share it with the client side, and they both can use the same token as they see fit. This approach, you could still share it with the server side by passing it off to the server side, but now it's going to expire, and there's no course of action to fix that other than to do the redirect again and go through authorization. Now, one of my favorite ones is Resource Owner Credentials Grant, which is a big mouthful of words. So some people call it the password grant. And what it really means, it's a little less OAuth-y than some of the other grants. Rather than ask the user for letting the provider ask the user for permission to access an API, instead the client itself asks the user for permission. In fact, they don't even have to do that. Instead, they simply say, hey, give me your credentials. It's kind of like that example I showed you up front with HTTP Basic. But where it differs from HTTP Basic is instead of using those credentials for every single request it makes to the server or to the provider, it exchanges those credentials one time for an access token. And then it uses the access token from then on out. It is expected that the client here would use those credentials, and then once it has an access token, forget them and not use them anymore. Now, a question that often comes up at this point is, well, how can we trust this app? How do we know that this app is trustworthy to do that? And you don't know. But and there is a potential security hole here. There's a potential lack of trust. But let me explain why they still allowed it and where they sort of justified the need for this grant. And again, if you don't like this grant, you feel that there's a security hole in place, absolutely don't use it. Go back to authorization code grant. But where this is commonly used is in a mobile client, especially a mobile client that is either native or presents itself as native, such as a web app that's wrapped in PhoneGap, for example. You wouldn't want to use this with a typical JavaScript client. That was probably a bad idea. And you probably wouldn't want to use this with a mobile web app that's not presenting itself as if it were mobile, but using it as for something that does present itself as a native app. It's kind of perfect because when you're in a native app and you're looking at some page or some screen in your native app, and then suddenly you're flipped around and you're showing the user a browser where they have to authorize an app, yes, that is more secure. I will acknowledge that. But from the user's perspective, this looks weird and I don't trust you anymore. It feels awkward. So although technically, yes, it is more secure, from the user's perspective, they get nervous about that, and they may not even go any further than that if you actually offered authorization code from a native or a presenting itself as native mobile application. Also, there is a greater degree of trust between an application that's in my pocket as opposed to an application that's on a server farm somewhere where I have no idea on the map where it's at. I have a higher degree of trust here. With this mobile app. There's nothing saying that mobile app won't take my credentials and do evil things with it. Absolutely not. It could still do that. And OAuth can't fix that because who's to say that an application couldn't do that anyway? Never mind OAuth. Just forget OAuth even exists. An application could ask them for their credentials and do evil things with them. OAuth can't fix that problem. In absence, it can't fix that problem. But in its presence, you can take advantage of the fact that someone might give you their credentials, and if you're honest and good about it and trustworthy, you can do the right thing and exchange their credentials for an access token that you're going to use on all API calls. Again, I will acknowledge up front, this is a little less secure than the authorization code, but it has its place. If you don't feel comfortable with it, go back to authorization code, and you'll be fine. Client Credentials Grant. Far less useful than the other grants by far, but it does have its place. This is a situation where we're not asking for access to an API on behalf of a user. We're asking for access to an API on behalf of the client itself. So instead of exchanging the client's credentials for an access token, instead of exchanging the user's credentials for an access token, we're exchanging the client's credentials for the access token. The client has its own credentials, its shared secret and ID. We exchange those, and we get back an access token, very much like what we did with Resource Owner Credentials Grant. It's equivalent if you're familiar with how OAuth 1 works, and it's what they call Twolegged OAuth. It's essentially the same thing as Twolegged OAuth in OAuth 1. It's just much simpler in its implementation. This is a very rare use of OAuth because OAuth is technically a user-centric form of authorization. But it does come in place. One place that comes to mind immediately is Facebook has their, I believe it's their payments API, as well as their, there's a couple of other APIs they have. They have one API that helps you dynamically create test users for the purposes of testing your application. Those are places where you would use your client credentials to invoke those APIs as opposed to using a user credential. Okay? Well, here's what that header looks like. Remember that ugly header I showed you before? This is much happier. And I've shown it to you for various drafts, although technically I don't think you need to worry yourselves with most of this, but I only show it to you in case you happen to come across an API that hasn't moved up the chain yet. I suppose they exist, but all the ones I'm aware of are actually somewhere between draft 13 and draft 31. Actually, I need to update that so it doesn't say 22, but you get the idea. So it's basically authorization, the word bearer, because there's a bearer token spec. I should mention that the OAuth 2 spec around the draft 11 time period split off into several different subspecs. One of those subspecs is called the bearer token spec. There's actually another way of doing the authorization header and another way of getting a token that is actually quite more secure, but it's also, in doing so, it's also very much more complex. And I would say for those people who are super paranoid about security, if you're a banking application, you're dealing with someone's money, this is a case where maybe you should consider that other spec if you're trying to secure your API with that. That said, I am unaware of any API that's using that more complex spec. Therefore, until I actually come across one that does, I'm not going to talk about it. We're going to focus on the bearer token spec because everyone using OAuth 2 is using that. So the word bearer shows up, and then you have the access token out in the open. And it's okay to be out in the open because we're sending this over HTTPS. If you try to send a token to Facebook, for example, and most of the providers do this, if you try to send a request with an access token to Facebook will, and it's over HTTP, Facebook will say, no, you can't do that. You have to come over HTTPS. They won't even allow you. Even if the token's good, they're going to say, no, you can't do that. So that's what it looked like in drafts 14 up to the current. It is slightly different in drafts 12 and 13 in that the word bearer was all capitals. But technically that wasn't different either because the spec also said it was case insensitive. But I still have to call it out because I am aware of at least one API that no longer does it that way. But they did attempt to do this, and they did not read the case insensitive part of the spec. And so if you did try to send it mixed case, it would not work. So if you come across one of those, that may be why. They may be around the draft 12 and 13 time period. Draft 10 had the word OAuth. At that point, we hadn't broken it out into multiple specs, so it was just the OAuth token. And then in 1 through 9, it was extremely ugly, and I doubt you're going to come across one of those, but if you do, that's what it should look like. It can be sent via an access token parameter, either as a request query parameter or as a form parameter, if you'd rather, but the preferred approach is to send it in the authorization header. Now, if we were to revisit that Facebook example, and here I am sending it as a query parameter, I'm going to send an access token to the Facebook API asking for the exact same endpoint that I asked for earlier. But now, rather than just seeing my name and gender and a few other things, you see a whole bunch of other stuff. In fact, I had to clip that and shrink it down just so it would fit on the slide. So there's actually more stuff there than what you see. It's actually telling you more things about me. Because at this point, with this valid access token, I have the right, my client, in this case the client is me manually entering this into a browser, the client has the right to see more stuff than I did before. Likewise with Twitter, we could do something a little like this. We would create that header, that authorization header, and we would make sure that that was in that, that request when we tried to send the tweet saying hello from S2GX. Now notice I purposefully left out how we set up the authorization header. And the reason I left that out is many reasons. Number one is this slide was going to get really hard to read if I actually put it in there. Number two, I showed you how to do that several slides ago with the word ARG on it. And number three is I don't recommend you do that at all. Although you could, I don't recommend it. Instead, that's where something like SpringSocial will come in and help you out. How many here have used SpringSocial? Oh, I love to see those hands. A lot of times I ask that question and I see nobody in the crowd and it makes me terribly sad. But I do find a few people who have done that, and it's great that you've used it. And for those of you who haven't, you're going to dig this. And for those of you who have, you're going to get to see a few new things that I'm working on that might make it really interesting. Well, the problem is with consuming these APIs, every API is different. And it takes you a while to get your head around how that API works. And it takes you a while to figure out how to form that URL. And sometimes you're lucky. The Facebook API is fairly easy to learn. The Twitter API is fairly easy to learn. Most of the APIs are fairly easy to learn. Occasionally they throw in these weird forms of URLs that are just impossible to understand. And certainly you're not going to remember what they are. And you're going to find yourself always referring to the documentation to figure out how to make that call. There's inconsistency in error handling. Everybody handles errors differently. Some of them just simply say, no, you can't do that. What you asked me to do, I don't understand it. Things like that. Facebook is a case where they do a really good job of telling you that, and Twitter as well, they do a great job of telling you that here's what went wrong, here's why we wouldn't allow that to happen, here's how we didn't understand your request, things like that. Facebook's exceptionally good at that. The one problem with Facebook is up until probably 6 months ago, they had some inconsistency in their messages. They would send you back, for example, if you tried to go to graph.facebook.com/ and then beat on your keyboard for a minute so you're giving it a bogus API, you would get back an error message saying, I don't understand the object. The object ID you've given me is no good. But guess what the HTTP status code was? 200. Everything's fine. I believe they fixed that now. I need to check that, but I believe that's fixed now, and they're giving you a 404 like they should. But there are some inconsistencies in the various APIs, and not everybody, certainly Facebook was not very good at this for a while, and a lot of API developers out there just aren't savvy and conscious of what should go into a proper API with regard to status codes, error messages, and so it can be a little tricky. Also just picking on Facebook one more time, I love them to death, I really do, but they frustrate me sometimes. They had an error message that as an error code, basically an error type, and the error type, no matter what went wrong, it doesn't matter at all what went wrong, the error type was always OAuth. Even if it had nothing to do with OAuth, it's OAuth. Essentially a useless field. I think they've started fixing that as well. You have the choice of XML or JSON. Up until, most of them are choosing JSON for obvious reasons. If you're consuming this from a JavaScript client, it makes perfect sense to give JSON, because it's already an object you can use. You don't have to do any really parsing or marshaling of the data. Some of them use XML. There's a handful that still use XML. Most of them are using JSON. Up until Twitter 1.1 came out, the 1.1 API came out, you had the choice with Twitter of XML or JSON. It was up to you when you made the request to put the appropriate extension on the end of the request to tell it what you wanted. With the 1.0 or the 1.1 API, it's JSON all the way. There's no option for XML anymore. Multiple versions of the draft spec. I already mentioned we have several different drafts of the OAuth 2 spec, and not everybody is up to speed on the latest ones, although most of them are getting there. You are going to have to get to know what your clients, what your providers are offering OAuth-wise, and you have to know how to deal with them. Signing the requests, not terribly tricky for OAuth 2, but incredibly tricky for OAuth 1, and as I said, unless you want to just sink 4 days into figuring out where you missed a single character encoding, I don't recommend you do it on your own. And then you have to deal with long-term storage and then of these tokens, including the refresh tokens. And if you do need to refresh a token, you need to be able to handle that and write the code to deal with that. So there's a lot of responsibilities for being the client of an OAuth secured API. Well, this is where SpringSocial comes in extremely handy. It allows you to connect with these software as a service providers or these lightweight API providers, primarily the ones that are secured with OAuth. That's actually the only security mechanism that SpringSocial offers currently, although it is, if somebody comes and says, hey, we really need to connect with this API that's using HTTP basic, yeah, we'll consider that. If somebody says, hey, we got this this strange security scheme, we'll consider it. If it's one of those one-off things, I would almost prefer it just to be an extension project as opposed to be part of Spring Social, but it would be a good thing to consider if we start seeing some other security mechanism creep up that's becoming popularly used. The nice thing about Spring Social is, even though it's primarily OAuth under the covers, it's all hidden behind abstractions, and so adding another security mechanism wouldn't be terribly difficult to do. It is an extensible connection framework. That's on purpose. That's because, quite frankly, the handful of people who are working on Spring Social just simply do not have the bandwidth to attack the millions of APIs, well, not millions, but hundreds of APIs out there that you might want to connect to. Just don't have that kind of time. We just can't do it. And so we made it extensible on purpose so we can allow the community to contribute to this. Whether it's a situation where you need to access some obscure API that we don't even know about, and so you build a one-off for your company and don't tell us about it, that's fine. Or a situation where it's a common API, something like Yammer, where a lot of people are using Yammer, and you would like to build an API binding for that and a Spring Social extension for Yammer, then maybe you could go off and do that, and in that case I would encourage you to come back and tell us about it, and so we can at least publicize your extension so that other people can enjoy it as well. And by the way, in case you're wondering, Yammer is already taken, so there is a gentleman who's working on that already. Here's if you want to check up on Spring Social, there's the website, plus as well as the Twitter and Facebook URL. Now, Spring Social is made up of these pieces. There's the core piece, which essentially has the connection framework, the things that deal with the OAuth dance, both for OAuth 1, 10A, and OAuth 2. There's also the web piece. The web piece is kind of extension to the connection framework. The connection framework works a little bit at a lower level, dealing specifically with OAuth. The web piece sits on top of that and handles all the redirects that must take place in the authorization phase, as well as a few other goodies we've tossed in there. One example, I don't think I'm going to talk about it later, so I'll go ahead and mention it now. One example of the kind of stuff you might find in the web level is there's it's actually specific to the Facebook project, but there is a web level Facebook feature that allows, if someone does disconnect your app from Facebook, not from your application, but they go out to Facebook and they decline your access token, Facebook will make a call back to your application, and we've got a controller, a Spring MVC controller defined for you that will deal with that and deal with cleaning up the connection on your application side. There's the various provider extensions. The ones that are under this category are the ones that I'm responsible for. We have Facebook, we have Twitter, we have LinkedIn. Now, all three of those are fairly well fleshed out. I will give credit. There's a gentleman in the community who did a lot of the work on the LinkedIn module, helped us out there. We also have TripIt and GitHub. Those have gotten a lot less love. I'd love to see those get fleshed out more. It just hasn't happened yet, and there hasn't been a huge demand for it, and the only reason I want to do it is I just can't stand the fact that they're incomplete. And then there's the community extensions, and this is, for all I know, not even complete, because I only know about these because I either found them accidentally or because someone told me about them. So if you're aware of any other extensions that have come about, please let me know about it. There's lots of community involvement in this project, and we've got all sorts of great API bindings and extensions out there. I should point out we got the QuickBooks Online there. That's one of those examples, again, of where this is not just about social APIs. And then, by the way, the Spring Android project, Roy Clarkson works on this, and one of the main features in Spring Android is an Android-ready version of Spring's REST template, which by itself is pretty cool and pretty valuable. But then he goes so far as to extend a little bit further, because he's offering the REST template in Android that enables you to use Spring Social on Android, in your Android environment, because Spring Social under the covers uses REST template quite some bit. But also he goes and offers a SQLite connection repository for storing connections when you make them. Well, I haven't talked about connections yet, connection repositories yet, but we're about to. And when you see me talk about the connection repository, just know that on Android you have the same option for SQLite. And Roy, at least on at least one or two occasions, has told me he's got an interest in a couple of other Android-specific connection repositories for those who may not like to use SQLite. Here's the key components you're going to deal with if you are building a Spring Social-based application. You're going to need connection factories. Now, the connection factory essentially is a thing that's very specific to a given provider. So there's a Facebook connection factory, a LinkedIn connection factory, a Twitter connection factory. These are the things that have configured the rest of the underlying, the lower level stuff in Spring Social to know how to talk specifically to their API, to this particular provider. If you want to create a custom binding, if you want to contribute to the project with an extension like I mentioned before, writing a connection factory is actually quite simple. It's usually one method with about 2 lines of code you have to put in it. It's very simple to do. You just give it some basic stuff like, yes, I'm dealing with OAuth 2 or I'm dealing with OAuth 1. This is the kind of thing I'm working with. And Spring Social takes care of the rest for you. There's a provider sign-in controller. Well, what provider sign-in controller does is it does its pseudo authentication. Something like what OpenID Connect is shooting to create a standard for. Provider sign-in controller does it based on Spring MVC. If you go out and look at Facebook and Twitter, and LinkedIn even offers this, they have the ability to do a sign-in with Facebook or sign-in with Twitter, and they have their own proprietary way of doing it. Provider sign-in controller offers the same functionality to any API that Spring Social has support for. There's a Connect controller. What Connect controller's job is, it's the web piece of that OAuth dance. It deals with the redirects. It deals with capturing the callback, the redirect coming back after the authorization. It deals with all the stuff that has to do with the OAuth dance that involves going out on the web and redirecting. Under the covers, it's using stuff under the connection factories and even lower level APIs to make the calls out to that provider to exchange things for access tokens and whatnot. But at the web level, that's what Connect Controller's job is to handle that for you. A connection repository, that's where you're storing your connections. Once you've gotten back an access token, once Connect Controller, for example, has gone through the process, gone through the dance, worked its way through the connection factories as an obtained an access token, possibly a refresh token, it needs to store these for long-term use. You don't want to have to do this for every request you make. You want to remember this and use it going forward. So Connect Controller will give that token and anything else it knows about that connection, give it off to a connection repository, and the connection repository will store it, probably in a database somewhere. There's a connection factory locator. Well, Connect Controller, provider sign-in controller, they need a way of knowing what provider you're trying to connect to. And since they are dealing with this at a web level, they try to figure that out from the URI, from the URL that hits them. So they extract a piece of the URL out. They use that to go look up a connection factory from the connection factory locator. So every connection factory is going to have essentially an ID, some sort of little plug that kind of references that provider. For example, the Twitter one is simply all lowercase Twitter. The Facebook one is all lowercase Facebook. It's going to take that and go to the connection factory locator and say, hey, give me the connection factory for Twitter, if you will. And then that way the Connect controller knows how to do its job going forward. And then finally, there's the API bindings. I kind of left that one for last on purpose. Let's be clear about this. The API bindings are the fun part of this. They're the part where you actually, the rubber meets the road. This is the part where you're making calls out to these APIs and you're making stuff happen. However, as cool as they are and as convenient as they are not terribly interesting on their own. They're just simply REST API calls that we bind to Java objects. They're valuable. They're convenient. I'm glad we have them. But the interesting part of this is actually going through that process, doing the connection process, and figuring out if the user has authorized your app or not. And so that's where we're going to spend a lot of time talking as we move on through this, is that piece of that, because that's more interesting and the complex part, and that's the part that's different, dramatically different, depending on which version of OAuth you're on. Okay, here's the things you're going to want to set up. Oh, yes, go ahead. Yes. Yes. Well, to a degree. I mean, certainly with the Facebook, Twitter, and LinkedIn, and the ones that I'm responsible for, yes, we maintain those. We do our best to keep them up in sync with any changes that may be happening with Facebook, that may be happening with Twitter, and so forth. Certainly things fall through the cracks. I've been really good lately about following Facebook. Facebook's been really good about announcing well in advance any changes they're making, but still things fall through the cracks. There's no question about that. So if you see something missing, by all means, submit an issue in JIRA, and I'll be happy to attack it. In the community projects, it's a little different because I don't control those, but it's essentially the same process, I'm sure. So one of the biggest examples of this is that the Twitter 1.0 API is going to be gone. It's currently in deprecated mode right now, and it's going to be gone in March. And so we're looking forward to getting that up to speed with the 1.1 API as soon as possible, so that we don't have any sort of, we're not down to the wire switching that over. But yeah, we do our best to keep up with that. But the fact is, we're going to miss things. There's a lot of little details that could easily be overlooked. Twitter is not as good about communicating their changes as Facebook is. So, except for that big change they offered, they're not. Otherwise, the smaller changes are not quite as good at communicating that. So it's easier to miss those. So here's the pieces you're going to want to need. You're going to need to configure a connection factory locator. You're going to need to configure the connection factories within that locator. And I'm going to show you how to do that. You're going to need to configure the connection repository. And there's actually 2 connection repositories, which is a great source of confusion for a lot of developers. I'll try to explain those the best I can, and then I'm going to show you how it might get a little bit easier after that. You have to configure your Connect controller. You'll have to configure any API bindings you might want to use. Optionally, you're going to want to configure that provider sign-in controller. Optionally, you're going to want to, if you're working with Facebook, configure that disconnect controller. You're going to want to create the connection status views, because when when Connect controller is going through that flow, they're going to show you the current status of your connection at one of those endpoints. And it's not going to tell you, it's not going to default to any particular view, any particular HTML page. And so you're going to want to have to create a page, a JSP page most likely, some Spring MVC compatible view that will show that. What Connect Controller will do is put certain elements in the model so that those views can render the status of your connection, whether you're connected to Twitter or Facebook or not. And then you're going to just, wherever you need them, inject and use those API bindings. At any point where you need to call out to Facebook, inject it in as a bean and use it. And I'll show you all of these pieces as we move forward. Now, there are 4 options to configuring Spring Social. The common option that most of our examples show is using the Java config approach. Plain and simple, the way it works in Spring Social currently, it's just easier to configure in Java config than in XML. It's not any sort of bashing of XML at all. It's just easier to configure in Java config than XML. That said, you could still do it in XML. There's just a little bit of extra care you had to take when you did that. So there are a couple of examples out there as well showing that, but most of them are showing the Java config approach. Now, one of the things that I'm working on, actually it's mostly done, aside from me doing some further testing and reevaluating it and having community feedback. You tell me where I screwed up. Is I've got a few new things coming that I've been working on to enable easier configuration, both in Java config as well as in XML, and I'll show you a taste of those in a minute as well. But first, let's show you the hard way again. I like to go this way first, because this is the way, if you have worked with Spring Social before, this is pretty much how you've probably done it. And if you've not, this is at least how it's going to work in the 1.0 version. You're going to declare a bean known as a connection factory locator. It needs to be singleton, yes, and it needs to be proxied such that you just need to have it as an interface proxy, and the reason for that is because it's going to end up being carried around in session at some point, especially if you're using the provider sign-in controller. If you're not using provider sign-in controller, you don't have to scope that with the proxy mode like I've done here. But if you are using in fact using provider sign-in controller, you do need to do that. Otherwise, you're going to have some problems with making it work. Within the connection factory locator, which is the interface, we create a connection factory registry, which is the implementation. And for every provider we want to support, we register a connection factory. So you see here I'm registering Twitter connection factory, I'm registering Facebook connection factory, and in both of those cases, the constructor is taking the shared secret and credentials for that application. So if you're not familiar with it already, if you go out to Twitter and Facebook or almost every one of these guys who offer an API, if you want to work with their API, you have to register your application. You have to answer some questions on a form, you have to hit submit, and upon hitting submit, they'll send you, either on a page or in an email, your consumer key and your consumer secret. That's your application's credentials. Or in the case of Facebook, they call it client ID and client secret, but it's the same idea here. It's your username and password for your application. It's your application's credentials. So that's where you do them here. You wire them in. Notice I'm not explicitly wiring them in here. I'm using the environment feature in Spring 3.1 to give them to me. In Java config, that's a great way of doing it. You definitely don't want to hard code those in here. Although you could, I don't recommend it. It's kind of a bad idea, especially if you're going to check this into GitHub. That's a really bad idea. Here we have our connection repository. In fact, it's the first of two connection repositories. Notice it's scoped as request. And the reason it's scoped as request is because this is going to be a per user connection repository. And it's going to happen on every single request when the user makes some hit on your web page and wants to call out to Facebook or call out to Twitter as a result of that hit to some web page. We need to know who that user is. Now, we could have hard-coded this, and we could have said, oh, you must use Spring Security. You have to use Spring Security to do this, and we think that's a great choice. We would be happy if you did that, but we don't want to make you use Spring Security if you don't want to. So if you're using some other security mechanism, that's why we didn't hard-code how we do this. That's why this is a little bit complicated here. We go to the trouble of figuring out who the current user is, and if we do have a current user, then we'll use that to identify the current user, in this case by their name. The idea here is in order to create a connection repository, we have to do that by calling to a factory method on another connection repository called users connection repository. We call out to that other connection repository and pass in some unique identifying name for that user. In this case, we're just getting the name from the authentication. If you're using a different security mechanism, it's up to you to figure out how you would implement that lookup for that user. Okay? Now, where does that user's connection repository come from? Well, it's actually quite simple. It's much simpler. It doesn't have to be request scoped. It's just simply create an instance of JDBC users connection repository. This is actually a connection repository that is aware of all users. It's a little bit more broad. It also doesn't have too many methods exposed on it. It's not intended to be used directly. It's intended to be used only really to create a connection repository. But here you give it your data source, wherever your whatever Spring data source you've configured already. You give it your connection factory locator so that it knows also how to look up a connection factory based on the provider ID, and you give it an encryptor to help it encrypt the credentials, or I'm sorry, encrypt the tokens when it writes them to the database. Now notice that here I've given it a no-op because, well, for development purposes, that's awesome. I would not recommend that in production. Okay, and once you've got that in place, you're ready to go. Now you may be wondering, well, wait a minute, what about, this is JDBC, what about other approaches? Some people have asked about JPA, some people have even asked about Mongo and things like that. Hang tight, I'll get to that. An in-memory connection repository? Yeah, so the question is, what is if there's another kind of connection repository where you might want to store it in memory or something like that? And the fact of the matter is, there is no other implementation of this as part of Spring Social that is other than JDBC. But it is based on an interface. There's a connection repository interface and there's a user's connection repository interface. So you're welcome to create whatever implementation you want and store those however you see fit, if it's in memory or if it's in some other database or what have you. There is an effort, there's a handful of people who've gone off and tried to do this in JPA, and most of them are pretty good, but they're a little different than each other, and I'm hoping one day that, and we'll talk more about this later, I'm going to unify that and kind of have a more standard approach with JPA, as well as Mongo and Neo4j and some of the other awesome databases that people are using nowadays that aren't relational databases. But we'll get to that in a moment. Now once you have that, well, now you can wire that into your Connect controller along with the connection factory locator, and now you have your Connect controller ready. At this point, assuming you have your dispatcher servlet and the rest of your Spring MVC set up, at this point you could redirect, you could link to the various pages that Connect Controller deals with, and it will show you it'll walk you through the process, walk the user through the process of authorizing your application. And I will run through this in a moment, and you'll see what I'm talking about. Here's the API bindings, how you create the beans for those. So what we're going to do is we're going to ask the connection repository to find the primary connection for the Facebook API, and likewise the primary connection for the Twitter API. Now, if we get a null back, now remember, this connection repository is for the current user. It's request scoped. It's who the current user is. If we get back a null, that means that that current user clearly does not have a connection to Twitter. Now we say primary connection because it is possible to have multiple connections, for a single user to have multiple Twitter accounts and have connections for all of those. We do allow for that. The typical case is you only have one or none. So if you have none, then we're going to say, no, we're just going to return a default Twitter template, which may, at least with Twitter 1.0 API, will give you still some functionality. In 1.1, it'll basically give you nothing, but at least you won't get a null back. you'll get exceptions elsewhere when you try to use it, but you won't get a null back. The Twitter, otherwise we're going to call Twitter.getAPI from the Twitter connection factory, or from the Twitter connection, and that will return an implementation of the Twitter interface or the Facebook interface in the first example. You want to use those? Just inject them and use them. Here's an example. We're injecting the Twitter API binding here, and then we say Twitter.timelineoperations.update status to actually post a tweet. Notice we had to call up timeline operations because there's actually several methods you could call on this API. We didn't want to litter the top-level API binding with just this long laundry list of methods, so instead it's broken down into kind of sub-APIs, and to get to the timeline-specific methods, you call timeline operations. There's also user operations and a few others as well. Here's how you make that connect controller work. You do a get to connect. That's going to show you it's going to essentially give you in the model a list of all the connections for the current user. You say get connect for a specific provider. It'll put into the model information of whether the user is connected to that provider or not. You post to a connect/provider. That's going to kick off the authorization flow. It's going to essentially, in the case of an OAuth 2 provider, it's going to redirect to that provider and start that flow. In the case of an OAuth 1, it's going to get the request token first, and then it's going to redirect for you. We do a get connect/provider $OAuth token and verifier. In the case of OAuth 1, in the case of OAuth 2, it's more like the second one down there where we have the authorization code. Either of those are the callbacks. After we've redirected to Facebook, redirected to Twitter, and the user has authorized, then one of those two is going to get called on the callback, and that's going to trigger for our application to handle the rest of the authorization flow. If you want to disconnect, you can disconnect a given provider. If you do that, that's going to remove all the connections for the current user on the given provider. Or if you want to give a specific one, you have to give that user's ID as they appear on the provider. So in my case, if I want to delete all my connections, for Habuma and Spring Social, I would call the first one. But if I wanted to only delete the Habuma one, I would call the other one, passing Habuma as the provider ID. Here's what the status view looks like. It's really basic. I'm not going to dwell on this too much. I encourage you to go look at the Spring Social Showcase, which I'm going to run here in a moment, and you'll see some of the details. This is how the connection status page works. It's going to show whether you're connected or not, and if you are, you're going to be able to click, or if you're not, you're going to be able to click a button. It's going to kick off that flow. Optionally, you can set up a provider sign-in controller. It's going to look a little bit like the Connect controller in many ways. It's actually going to go through much of the same flow as the Connect controller. The only difference between the provider sign-in controller and the Connect controller is at the end of the flow in the Connect controller, we're going to create a brand new connection. We're going to take that token and create a brand new connection. At the end of the flow with the provider sign-in controller, we're going to take the token we got, and we're going to go see if there are any other connections in our database, in our connection repository, that have that same token. Actually, that's not true either. We're going to take that token, and we're going to look up the user's ID from the provider, and we're going to go look and see if there's any other connections that have that same user ID from that same provider in the database, and if we do, we're going to automatically sign that user in. If we don't, then the user is going to have to try again. We're going to throw them back to a login page. You configure it very much like you would the Connect controller. The only extra thing you have to give it is the simple sign-in adapter, because we need you to tell us how you want us to sign in the user. Now, simple sign-in adapter, as you see it here, is implemented such that, well, it's not clear what it does. And in fact, from the Spring Social Showcase, how it's implemented is to use Spring Security to do that. But we kind of left it up to you to implement the sign-in adapter interface. One of the things that I've realized is that everybody's doing it with Spring Security almost exclusively, and so everybody out there is essentially writing the same implementation of sign-in adapter. So I'm seriously considering creating a Spring Security sign-in adapter and just letting you guys use that as opposed to having you create your own. And then if you want to create your own from some other mechanism, you can do that. The provider sign-in controller, very similar set of endpoints, but much simpler because we don't care about status, but it's more or less the same flow as we saw before. Now, this is brand new. This is 1.1.0, and it's in build snapshot. If you were to go pull the 1.1.0 build snapshot release of Spring Social, you could use this. And as well as Facebook and Twitter, you're going to have to use those with it as well. It's in place if you want to use it. That said, I just want to give you the basic disclaimer. This is not any sort of announcement. This is not guaranteed that this won't change. This is just what it looks like currently. And I stress that for two reasons. Number one is you shouldn't have any expectations, but also at the same time, I encourage you to tell me if I've done this poorly. Give me feedback on this and let me know if this doesn't work for you, or if you think there's something else that needs to be done here. But remember all that XML, well actually I showed you Java config before, I didn't show you the XML, but trust me, the XML is just as hairy as the Java config I showed you. Well here it's quite simple. Facebook config, Twitter config. I give it an app ID, I give it the server, the secret, and Facebook has this notion of a namespace that they use primarily for their open graph stuff that they do. And you don't have to give it the namespace if you don't want, but if you do plan on using any of their open graph operations, you must give it your application's namespace. So here's the app ID, here's the secret, here's the namespace. In the case of Twitter, I just gave it the consumer key and secret. What's happening under the covers there is a lot of things. It's actually creating the connection factory locator if one has not already been created. It's creating the connection factory itself for Facebook and then for Twitter. And it's also assuming that we have the connection repositories in place. It's going to go ahead and create the API binding beans for Facebook and Twitter. So that's the last thing you have to do with Facebook and Twitter other than just start using it. Here we have the JDBC connection factory. Again, it's going to do all those things I showed you that required 2 beans worth of configuration. That one line's got it now. There are some attributes I'm not showing you there where you can give it a different data source if you want. There's a few other details, like perhaps if you wanted to pick a different encryption algorithm. There's things in place that I'm not showing you here, but that's pretty much all you need. And then finally, here's our user ID source. Now, the user ID source, that's going to be necessary in figuring out who the user ID is. Remember for the connection, or I'm sorry, for the connection repository, I had to go figure out who the current user was. Well, I don't know of a good way of doing that in the XML-based configuration. So instead, I have a thing called a user ID source. And here I have a very long named one, Spring Security Authentication name user ID source. And because I've given it a bean ID of user ID source, that other element right above it is going to default to that. But if I wanted to give it a different bean name, there's certainly an attribute where I could give it a different one if I want. But within that bean, within that class, is the stuff that's going to go look up the current user's name from Spring Security. Well, that's much simpler than what we showed you before with the Java config. Here's where the Connect controller would come into place. I didn't create any special XML elements for configuring the Connect controller because I just didn't think it was necessary. I think that's sufficiently easy as it is, so I didn't change that any, although I did use an auto wire there to make things a little bit simpler. Other than that, I didn't change it much. Here's what that user ID source looks like. Notice it looks shockingly similar to what I showed you in the Java config before. It's because it's doing the exact same lookup to figure out who the current user is from the authentication. And once you have those together, what you have is a very basic XML-based configuration for Spring Social. You want to add LinkedIn to this, all you have to do is go up there and say LinkedIn config and give it your LinkedIn credentials, and you've just now added LinkedIn to the mix. Here's the equivalent stuff for 1.1.0 Java config. Again, not an announcement here. It's subject to change. In fact, I've got a few ideas of how I might tweak it to make it even a little bit cleaner than it is now. But here's how it currently works in the snapshot build right now. I basically enable Twitter, very much like the Twitter config you saw before. I have an enable Facebook, very much like what you saw with the other one before. I didn't give it the namespace here, but I could have. I enable the JDBC connection repository. I set up my Connect controller. I inject all these other things. Now, the connection factory locator, the connection factory locator is going to be given to me as a result of enable Twitter and Facebook. The connection repositories are going to be given to me as a result of enable JDBC connection repository. But I had to inject them here so I'd have a reference, so I'd have a handle to them from which I can create my Connect controller. Now, again, I have some ideas of how I might tweak this a little bit, so keep an eye on it if you're interested in it. I think this is significantly simpler. I'll be honest with you, I grew weary of doing a talk like this and explaining to people how the connection factory wiring works. So it's good to know how it works, but it's not necessary, I don't think, to know how it works if you want to use Spring Social. So I'm trying to make it where you don't need to know it anymore. Let me show you that demo. And check my time. I got about 10 minutes. I think we're doing great on time. Let me show you the demo. I've got Spring Social Showcase running. I've actually logged out of Facebook and Twitter already, so it's going to actually walk me through the entire process. I'm going to go ahead and log into Spring Social Showcase using my username and password, which is a huge secret, as you can see. And there, I'm signed in. Fantastic. Now, the menu on the left side isn't showing me anything terribly interesting. It's showing me Twitter and Facebook and LinkedIn, but because I'm not connected to any of those yet, I don't see any additional operations under there I can do. So let's go ahead and deal with Twitter. Well, this is going, if you look at the URL, it's actually going to the connect controller. It's going to /connect/Twitter. So /connect/Twitter is going to show me the connection status for Twitter. If I left that off, I could go straight to connections, and it's going to show me the connection status for all three of my providers. But let's focus on Twitter. Connection status for Twitter is I'm not connected. So I need to connect. I'm going to hit that button, and it's going to help me connect. At this point, before I hit this button, let me explain what's about to happen. As soon as I hit it, there's going to be a post that goes back to Connect Controller. Connect Controller is going to use the connection factory to go get a request token, and then it's going to do all the nonsense it has to do to get me redirected to Twitter. And there I am. I'm redirected to Twitter now. And it's asking me to authorize Spring Social Showcase, and it's telling me what I can and can't do. And because I'm not currently logged into Twitter, I have to sign into Twitter first. Had I already logged in, it would just simply ask for permission and not for my credentials. So let me go ahead and log in as Spring Social. And let me see if I can remember what password I'm using for this account. And we'll authorize the app. So yes, it worked. It's redirecting me back. And notice I'm now connected, but also I have some additional functionality on the left side there. I can do things like, basic stuff. See my profile. There's some details about Spring Social user that I pulled from Twitter. I can go see the Spring Social timeline, which there it is. There's the various tweets that have been sent on it. I can go see my friends, which I am actually not following anybody via this account. Therefore, that list is empty. But there are some people who are following Spring Social. Maybe it's some of you guys. And there they are. So here's a list of those. If you see your face, then good for you. And there's some other stuff you can do. But I was only able to do that because now I'm connected. Let's try Facebook. Very similar situation. Here's Facebook. I'm going to sign in with Facebook. And apparently I got my password wrong. Does anybody remember what my password is? It's one of two things, and it wasn't that one. If I don't remember it, suddenly my social life is going down the drain. Oh, there we go. Okay, and also what I made a point of doing before I got here is I went and disconnected on Facebook's end. I revoked my authorization. Had I not revoked my authorization, it would have redirected immediately back to Spring Social Showcase because the authorization would have still been good. The authorization I'd given it previously would have still been valid. I was just sort of upping that again. But here, I had revoked it, so I don't have an authorization currently for Spring Social Showcase, so it's asking me if I can do that, so I'll agree with that. You've probably seen this dialog before if you've ever used Facebook. And then there's what's known as extended permissions. This is where it's asking for additional things other than the basic stuff. Is it allowed to post on your behalf? Sure, I'll allow that as well. And here we go. Now I have some Facebook operations I can do. You can see my Facebook profile. You can see my feed, and I'm scared of what might be in there. There, my daughter made a bunny out of straw wrappers. It was quite impressive. You can see all my friends. You can see different photo albums, and that's that. LinkedIn, I could bore you with the details. Here's how LinkedIn works. I am already logged into LinkedIn, so it's basically asking me if I still agree to this permission I'm granting. They take a slightly different approach. Rather than just go ahead and redirect you back, they say, do you still agree? We already have an authorization for you. Are you still cool with that? Which I think is kind of nice if you think about it. And it sent me back. Now, I'm connected to all three of these. Let me go up here and sign out. Now, I'm not signed into Spring Social Showcase. I am still connected with Facebook, Twitter, and LinkedIn, however. And so now I have the option of signing in with any of those. So I can sign in with Twitter. Look, I'm signed in now. What it did is it went out to provider sign-in controller. It went through the flow. It got a token. It looked up my current user ID, compared it with IDs that are in the database, and said, hey, it matches up with Craig's. Let me sign Craig in for automatically. I didn't have to enter any credentials. Well, let's do that again. It's not terribly interesting, but I get the same thing with Facebook. And the only thing that makes LinkedIn more interesting is really that it has a less interesting button and that it's going to oh, it didn't. I'm a little surprised. It didn't ask me again to reassure the authorization. There is a parameter you can send to do that. I just didn't realize I was sending it. And so there you go. That's Spring Social Showcase. Well, I can go a little bit further, and I can do things like disconnect from Twitter. And now that connection no longer exists. And when I go up here, sign out, and attempt to sign in with Twitter, it won't be able to. So instead, it's going to give me an opportunity, if I want to go ahead and register as a new user, after which it will automatically create a connection between that new user and Twitter if I want to. Optionally, I can go back to the sign in and pick some other approach to sign in if I want. All right. Let's wrap this up. Here's the next steps in Spring Social, both for you and for me. Starting with me. Again, this is not an announcement. This is subject to change. It's things that are in the plan. That's why the word planned is in italics. Feel free to tell me if you have better plans for me. I'll be willing to consider them. But here's the plan right now. First off, the simplified Java and XML configuration. I've already shown you a little taste of that. It's, like I said, more or less done, but I am considering a few other tweaks to it to make it a little bit nicer. There is a great desire in the community to have tighter integration with Spring Security, aside from just simply looking up the user as I've done before, but a much tighter integration. There's a handful of folks who have gone off and actually implemented something along the lines of this, and they all seem to have good stuff. What I'm needing to do is sit down and kind of consider their attempts and somehow unify them. But that's probably one of the next big things that needs to be done. Definitely one of the next things that needs to be done is automatic handling of expired or invalid tokens. So currently, at the low-level APIs that Spring Social offers, which I didn't even show you because they're not terribly interesting, they require that you know OAuth more than the high-level ones were. At the low level, it is possible that if you have a refresh token, that you can exchange that refresh token for a brand new access token using the low-level APIs. But at the connection framework level, at the higher level APIs, there is no clear way of doing that. And so it's not impossible to deal with an expired token or even with a revoked token. If somebody revokes your token, it's not impossible. The very least you can do is walk your user, redirect them back through the flow again. You can do that, but it's up to you, the developer, to handle that situation. What I've got in place, and I would say it's about 80 to 90% functional at this point, is I have an automatic handling of that, so that if any time in the course of a request I realize that your token is no good, whether it's expired, revoked, or otherwise just a piece of junk I can't use, I will deal with that appropriately. Ideally, in the case of an OAuth 2 provider, I will attempt to find a refresh token and deal with it on the spot. If I can't do that, such as the case with OAuth 1 or Facebook, because they don't offer refresh tokens, I will basically redirect you through the flow again, get the user to authorize again, and then try to pick up where we left off as much as I can. And I'm taking some inspiration from how Spring Security does the same sort of thing. If somebody attempts to do something that they don't have authorization to do, or they haven't signed in yet, it'll walk them through the sign-in and then allow them to come back and attempt to do it again. OAuth 2 password and client credentials grant. This is actually already in place and in the snapshot builds. Let's see, I implemented the OAuth 2, the password of the resource owner credentials grant. That works. It works at the lower level API level right now. The only thing remaining for me to do is to also bump it up and expose that in the higher level API so that once you get a token through the password grant, you can store it in a connection repository. Again, you're probably not going to care about that unless you're using this on an Android device as part of an Android app, but I do need to finish that out. Client credentials, this is a situation where you're getting a token on behalf of the client itself. There's really no need to store this connection. All you just need to do is somehow remember the token itself. So I have no intention of ever tying this into the connection repositories because it just simply doesn't make sense to do so. But there is a gentleman in the community who contributed a pull request to help me with this piece, and it's really straightforward. It's just a simple REST call to do that. I am considering, although I have not dedicated any brain power to it yet, I'm considering some additional connection repositories for those people who aren't using JDBC who might be using JPA, but even more interesting, who might be using Mongo, Neo4j, potentially some of these other schemaless databases. I myself am a fan of both Mongo and Neo, so those are the ones that come to mind immediately. The problem here is if you are building an application that's using one of those databases as your primary data source, you are kind of stuck using Spring Social because you'll be forced to use a relational database just for the connections, and I think that's horrible. So I'm hoping to be able to fix that for you. API binding updates, certainly I've already done a little bit of this work. There's another gentleman in the community who's done some work on the Twitter API specifically, scouring the latest docs to make sure that the API bindings are in fact up to date. And of course, if you see anything we missed, let me know. We'll see if we can fix that. Signed request. There's a thing when you're dealing with Facebook specifically that there's another way of doing authorization that's still OAuth-y, but it happens almost entirely on Facebook's side. It's when you're doing like a Canvas app in Facebook or a tab page application in Facebook, they will just give you a signed request. And from that signed request, within there will be an access token you can use. You just have to decode it and get it out. There's currently no support for that, but there is, I can't remember. It seems like I actually did implement this, and it's in the snapshot. I just don't remember if I finished it out or not. I'm pretty sure I did because it was actually dumb simple to do. But it's coming if not completed. API bindings for the Open Graph operations, that I do know is in place. You are able to now do things like what Spotify does to say, hey, so-and-so listened to this song. Well, if it's your application, so-and-so just did something on this application. You can do that with their Open Graph operations now. That's precisely why in the configuration steps I allowed for you to give us a namespace, because you need the namespace to be able to do that. API binding support for the Facebook query language, that's also in place. It draws inspiration from how JDBC template does SQL queries. You give it a Facebook query language query, and it will come back in a callback and give you that data to work with however you see fit, which is kind of nice because if you think about it a minute, even though the Facebook API and the binding and the Twitter API binding and LinkedIn API binding cover a great deal of those individual APIs that they bound to, we probably missed something, as I said. And even if we didn't miss something, who's to say that Facebook won't roll out a brand new endpoint today that we just didn't cover? And if you want to use that, need to use that now before I get a chance to get it into the API, you always have the option of asking for the underlying REST template that is behind those API bindings. And the difference between that underlying REST template and one that you just might create on your own is that underlying REST template is already wired up to make sure that the request has the authorization header you need in it. It's not just a plain vanilla out-of-the-box REST template. It's one that already knows how to sign the request for OAuth. So that's a kind of nice feature, but another feature is there may be things that you just simply can't get out of the Facebook API. Even if we wanted to give you a binding for it, the Graph API itself does not offer what you're asking for. Well, another way of getting at it is through their Facebook query language, where they have this sort of conceptual notion of tables that you can query from. And so we support that, again, very much like what JDBC does. That I know is in place and in the latest binding. And there's also support for Twitter's streaming API. That one I actually started work on a very long time ago, and I got busy with something else and had to put it aside. But as I recall, it was working perfectly. I just needed to do some further testing to feel good about it. So I'm going to resurrect that one soon, hopefully, and just put it away and call it good. But again, these are just things that I have in mind. They are subject to change. No promises being made here today. Now for you, Spring Social is a social open source project. I encourage you to get involved. Discuss in the forums. Go to the forum. There's a URL for the forum. Bug me, bug other people, and even better, don't ask me questions, answer people's questions. That would save me some time to get some of that other stuff done. That would be awesome. I know there's, at least in some of the other forums, and there's actually a couple of guys in the Spring Social forum who are really good about answering questions before I even get up in the morning. I wake up in the morning and questions are answered for me. It's kind of nice. So feel free to do that if you want. Suggest some improvements. Go out there to Jira URL/browse, one of those things. And for the individual projects, so we've got the core project, Facebook, Twitter, LinkedIn, TripIt, and GitHub, and make suggestions, contribute, tell us if something's broke, submit a bug. That's one way of being a part of our community. And contribute. By all means, fork our project if you see an opportunity to improve it. Make your changes, submit a pull request. We will ask you, before we merge the pull request, we will ask you to sign this little contributor agreement that makes the lawyers happy, but it's really a fairly insignificant thing you have to sign. And then we'll be happy to merge your stuff after we review it and maybe have an exchange with you over what you did. And then finally, you can create new extensions. The nice thing about creating new extensions is that's not our code. We're not going to merge it in with our project unless we see a huge value in it. We're not going to merge it in. You don't need to sign that contributor agreement. That's your project. It's like those 25 or so other projects I showed you before. That's yours. You can do however you want to, whatever you want to with those, and just let me know about it, and I'll scream it from the mountains. I'll tweet it from the Spring Social account. I'll tell the world about your project so that they can come and help you work on that if someone's interested. Thank you very much. That's the end of my talk. That's the end of the conference. I hope you had a great time. I know I did, and hope to see you next year.